Okay, so good afternoon, and this is me. I don't know if you can see the camera well. We are supposed to meet physically, right? But because of my schedule, the time that I always put you, something comes up. So I want to take you through something, okay, so that it gets you occupied tomorrow. I'm recording this on Friday, so it gets you occupied tomorrow before we meet. And as a result, I'm going to design an assignment for you to solve, okay? Take note. What we are doing, we've not started any programming language just yet. It's going to span across a time. We've met. I think Saturday we couldn't meet, so we met on a Sunday, or at least you got materials to interact with on a Sunday. So now today, what I'm going to now talk about is basically what you have seen so far. So based on the materials that I told you to go and read, you've captured the following. So I'll start from here blank, and I need text box, right? So based on what you've read, you've captured the following. You've captured the concept of algorithm. You've captured control structures. You've also captured operators, and the last one is uh, data types and then variables, right? Okay, so you've done all this, and well, there's a guide. Let me see if I can find it. One, two, three, one, two, three. I don't know whether it's here, but we'll be going through the following. Hold on. Summary. Okay, so we'll be going through the slides that I gave you gradually, and we've done intro to algorithms. The next one on the list was I think data types and variables, and then from there we saw operators. Okay, we saw operators. Now from operators we go to the control structures. In the control structures we talked about three things, which were loops. We had the sequence control structure, and then we had the decision making. We had the decision making, and then we had the looping control structure. Now these exist on their own. So in the slide called control structures, we are going to break them down into their own structure. So although I listed them up there, you can see now they are bulleted. So we've done algorithm, we've done data types, we've done operators, we've done control structures. Now we are going to go into control structures. Go to control structures into detail. Okay, so we'll now start tackling expressions. So when there's an expression, how do we go around it, right? All right. I have some slides, and this one will not be with animations as the one that you've seen. Okay, so let me see. I can get those slides. Let me see. Right. So we've done control structures. So now that's a slide called instructions. So let me open that slide and then we'll deal with that. You can skip the animation part. All right. So, oh, it's already here. Now, when we talk about an algorithm, we want to have a task done. And so, what we would want to help us get a task done is what we refer to as an algorithm. That's basically it. So an algorithm is basically our way of why is the thing not going? Algorithm is our way of getting a task done. Okay. But the person who is going to do the task is the computer. So the moment we write something in the language of the computer to cause the computer to perform a task, we are making use of an algorithm. I hope it's clear, right? So that's it with an algorithm. That's it with an algorithm. Now, so there is this scenario I created. I'm sure you've watched this video again. Like you've watched it, so I'm going to brush through. When we are getting instructions from our parents in the house, what usually happens is they give the instructions stepwise. So they would expect you to do the instructions as was given to you. As a result, having your African mother leaving the house and then giving you this instruction, Kojo or Kelvin, when you are leaving at 7 o'clock, when I leave, or she wouldn't even say that. She knows that she's giving an instruction because she's not going to be around. At 7 o'clock in the morning, sweep the compound. Because she said this one first, you want to start with this instruction. And then the next one is wash the dishes, bath your siblings. If the bin is full, empty it and change its position. And then while I'm not back, look after your siblings. My mother gave you these instructions. You are supposed to make sure you are done with them. In a computer too, similar thing happens. The set of steps that we follow is what we term as the algorithm. When we are cooking, we use a similar concept. We make sure we cut the onions, we do all of those stuff, and then eventually we are going to parcel everything into the stew or the rice, that thing that we would be using. So now, let's take a look at this one. We were given instructions, and a critical look at the instructions helps us to know that they were numbered. So one is first on the menu. Get rid of that one, then we move to the next one. Until we are done with the first one, we'll not move to the next one. That's how a computer thinks. So I'm going to try with a question. This one is not in the slide, but that's basically after I'm done treating this. So there is something that helps us to know. Okay, mother gave me a set of instructions to offend and I carry out. Now the instructions were numbered 1 to 5. But how will I know whether I'm supposed to even start with number 1? So in computing or when programming, there is this thing we talk about and it's called control structures. Control structures will help you to know where you've gotten to, that's one. Secondly, it will help you to know which line to execute first or execute next. Let me use the word next so that you know that, okay, right now I've done all this. I'm supposed to do this one next. All right. So when it comes to that, sequence control is what helps us to now know that a computer will execute statements stepwise. It will start with the first line, go to the next line, go to the next line. Because all those numbers are numbered, it will always follow that sequence. Now, if you remember, we saw something here which said, if the bin is full, empty it. Now there is a condition. So it means that statements that we even have in computing or in programming, some will be executed and others will not be executed because at a certain point in time, some conditions will not be satisfied. When we read this, it's not all the time that the bin is full. So when we get here and the bin is not full, we will not empty it. That's basically what this statement means. And this helps us to know that not all statements will be executed in the programming code. All right. The third one says that looping. And looping control structure helps us to know that, oh, okay, I'm supposed to repeat this particular task over and over and over. So I'm going to do a little demonstration. Make sure you pay attention. Now, as we start doing all these instructions based on what mother said, at 7 o'clock we'll sweep the compound. But you should know that this one gave a time. So if it is not 7 o'clock, we will not sweep the compound. So we'll wait till it's 7 o'clock before we sweep the compound. This one even helps us to know when we are going to start executing the instructions. Because if it's not 7 o'clock, although I can wash the dishes, according to her instructions, she numbered them and she said at 7 o'clock, sweep the compound. So it means that if I'm supposed to do anything at all, like washing the dishes or bathing my siblings, I have to do it after I'm done sweeping the compound. The next one now says that if the bin is full, if it's not full, I don't empty it. The next one now says, while I'm not back, look after your siblings. This one helps us to know that I'm supposed to look after my siblings continuously until she's back. Please take note of this. This one helps us to know sequence control. So the sequence control is basically we getting to know that, okay, a computer will execute the statement from left to right. While I was reading the instruction, I didn't start from here, go here, go here. It's a line. So I read the whole line, moving from left to right. And then the dishes, washing the dishes was the next one, also from left to right. But you could see that I did not read the sentence at 7 o'clock, wash the dishes. No, I read it from left to right until I was done with that line. So if you can have multiple statements on the same line, but what will happen is you need to finish one line before you go to the next. Now I want to do something here to help you get this. Let me get an empty slide. So I've told you that a program will start executing from the top. So pay attention. If not, you will not get this. If I start my program and I say, what is your name? And that's the first question in the program. And I come again and I say, really? So your name is John? Who's this? Hold on. So let's say after the first question you responded, your name is John. And I ask, really? So your name is John? And then you answer with something like a yes. And then we proceed. John, get me your form. Something like this. Right? This is a statement. And then you bring the form and I'll say, please sign here. Now, I've left a space and I'm going to write something here. Did you sign there? If you tell me no, I'll now say, if your answer is no, if your answer is no, this one is a question, something like a question. And then if your answer is no, start, and I'm a go to intro. Now with that, I'm going to give this whole thing a background. Where is it? The yellow item. You let me just say go to yellow. Oh wow, it's great. So the instruction here is we have a simple program. Okay, one is highlighted yellow, and so if the instruction here says what is your name, you answer your name is John, and I say really, so your name is John. Go to the next one saying John, get me your form. You give me your form now. I tell you, please sign here. After you signing or not signing, the next instruction asks, did you sign there? which is the place that was asked you in the yellow background. If you say no, now they are saying start again. So you start. Maybe you are John, and then they ask the question and you don't sign there. They will ask you go to yellow. You follow the same procedure and you don't sign. They will tell you, did you sign there? If your answer is no, then go to yellow. So this one continuously happening means that the condition, which is your answer is no, this condition is always being true. Now we've talked about Boolean operation, so that one has to do with something being true or false. So this one has to be do with something being true. And so if it is true, then go to yellow, go to yellow, go to yellow. So that has to explain the part where we now say some statements are repeated. All right, so what we did was the control structure, those things that we saw. I've told you that a control structure gives the direction in which we execute statements. So those are control structures. All right. Now, in this case, we have sequence control. I've spoken about that. The line-wise execution of statements. And then we move from left to right as well. So a typical example is given like this. If we have two statements, so we'll execute both by starting with the first one on the line, going to the next one. All right, so we are done. Some of the basic algorithms that we have day to day, we have recipes, sorting papers, traffic signals, bus schedule, gardening. The next one talks about some of the statements that we saw in mother's instructions. And the first statement had a condition inside saying at 7 o'clock. Okay, so we can't skip one statement to go to the next. If one of the statements over here said, instead of if the bin is full, empty it, and rather said if the bin is full, go to line 1, you will wait again till it's 7 o'clock before you sweep the compound. And then you will wash the dishes, bath your siblings. If the bin is full, you will do it again. And that is what causes the repetition happening. So this is it with instructions. Our next slide focuses on inputs and outputs. So since you started with Python a little, I'm sure you've seen something like the print statement. So in this slide, we are going to talk about what do we mean by outputting something on the screen. So by outputting something on the screen, what we are doing is we are showing the user a prompt. Okay, let's start with the input. So an input is equivalent to you filling a form. The form has spaces or more or less labels and underlines. So you are supposed to enter the name on the provided space, and then the next one is the label will be there. So the label will now describe the underline that has been shown. Okay. And so anytime you remember we talked of variables. And so variable has to do with a container that we are going to keep an item inside. So input data refers to any kind of data fed into the computer by the user. This is usually made possible by the use of the keyboard. And so the moment someone starts typing from the keyboard, we having a program or having written a program, the person's data or response to what we showed him is going to be kept in a variable, given a particular name so that we can use it later on. The next thing that we also need to take note of is after we are done taking inputs, we need to display something to the user, or we display something to the user to effect him inputting something, right? So this is usually made possible by output device. So we have monitor, speaker, and all those things. They help us. Now, when a user is interacting with a computer, he responds to questions that the computer is asking him by using the input devices. If I say, what is your name? The first thing you will do is you are going to enter from the keyboard by using the keyboard. What you will give me, I refer to it as an input. And then what you see in order to now give me something is called the output. Now, commands for getting input. In Python, you have a command called input or raw input. That helps you to be able to supply your answer for the question that was asked you. But over here, because what we are doing is called structured programming, or we are trying to take a look at programming from a point of view, no language, we are going to use verbs. When I say tell me your name, I'm using a particular word. The word is what? Tell. So I'm expecting a response from you. If I say give me your name, I'm still taking an input. So words like that are used to collect inputs. And so anytime you see something on the computer, it's either they are displaying you a normal output, a prompt, a display message, a result after a particular computation. All right. Then we come to input verbs. So these are verbs that we use anytime we want to take something from the user. So when I say input your name, I'm expecting you to give me your name. When I say get name, I'm still expecting an input. So get it for me. Take, accept. So with that is the computer that's saying accept name, enter. So those commands helps us to now get names from you. This one is a mistake, right? We don't have enter here and enter here. Enter is only when we are instructing you to give us data. And we have output, we have put, we have show, we have display, and we have print. There are multiple verbs that you can use to take inputs or display results. All right. So this is basically an example of how we use it. So anytime you want to say, get me the name of someone, you would want to write it this way if you are writing the normal structure of an algorithm. Input name. If you want to display something as a string, in Python you say something like output print, then you put the string in quotes. In Python, you wouldn't write get age. You have an input method or a raw input method that you put your string inside. So these are basically how we'll be writing our algorithms. All right. So this is the lesson I want you to watch before I come up with the next ones. Okay. So I'll send you the link. Okay. By the time you see this, it means that I've given you the link. The next on the line is sequence control structure. I think we've taken a look at that one already. So we'll move to selection control structure. I'll give a brief explanation and then we'll start tackling algorithms from okay. So the selection control structure helps us to know which instruction to execute given a particular condition. If a selection control structure allows one of a set of statements to be executed if a condition is true, and another set of statements if a condition is false. So when you look at this box over here, I've written something here calling it a condition. Today is Friday, so if I write in the green box, today is Friday, what a green box does is it's more or less the center of truth. If it checks and today is actually Friday, we will do what is inside the box. If it checks and today is not Friday, we will not do what's inside the box. That's basically it, right? Now, we have a condition, which is more or less the entrance to the big box. And then inside the big box, we can do whatever we want. But remember, because of the sequence control structures, we keep it line by line. And so when we are done with all the lines inside the big box, we will jump out and go to the next line. If there is a box, we will follow a box. If there is no box, we will just be there. And that will be the end of the program. So right now, we have if, then a condition comes, and then a set of statements. Then we end the if. We have a green box which says true. Now, because this is the center of truth, when we get to this point, we check the condition. If this particular part is true, we will enter the box. If it is not true, we will not enter the box. So imagine we are moving from the top. We get to this part and we see, oh, this part is true. It means that we can enter. When we are done entering, we are supposed to do all the actions in the big box. When we are done with the last statement in the big box, we will jump out. All right. If it is false, the moment we get here and this condition is false, we will pass by it. All right. So we will not enter it because the condition is false. I'm sure you will have a question. Why is it that you write a condition that will be false and then we wouldn't execute the actions? It's not all the time that based on the parameters that we have, we are able to get this condition matching what we want. Sometimes we will have someone being called John and he's passing in front of a shop and the shop has signposts. If you are Mary's friend, enter and come for cake. Now, enter and come for cake is the action in the box. But you need to be Mary's friend before you enter and you come for cake. Because it is John that is passing, and John is not the friend of Mary. John is actually the husband of Mary, but they are not friends. So John cannot enter the shop. You understand? So basically, if I say sometimes the condition is false, it's based on the parameter. When Martha passes by, Martha is a sister, Martha will also not enter because Martha does not match the condition. But imagine Mary had a friend called Peter. Peter is passing by. Because Peter is a friend, this box will not be false for Peter. He will enter and do the actions and then leave. When he leaves, if there is another shop he's supposed to see signboard on, he will enter. Or if there are no signboards, on his way home, he may do some actions, and those are the actions that may follow the program. So we have different kinds of if statements or decision making. We have the simple if, and then we have the else if. The else if now has two boxes, but those boxes we have just one condition. This condition says that if this is true, enter this box. But we have the else clause. Else clause says if this is not true, okay, if based on the conditions that you have, this is false, then enter here. So at the point where Peter gets to the shop, John gets to the shop and they said, oh, you are not a friend of Mary, so don't come for cake, but rather come for a bottle of wine. So you don't get cake, but you get wine. So getting wine is by you entering this other box instead of the box that has a condition. That's the else statement. And then we have if, else, if, else, if, else, if, and then finally else. So I say, okay, if you are a boy, pick the broom and sweep. Else, if you are a girl, go to the market and bring us food, something like that. Okay, let me turn it around. If you are a girl, go to school. If you are a boy, go to the farm. I think that one sounds better and not racist. All right, so if we have the if statements come with conditions. So if, then there's going to be a condition. Moving from top, you will get into this box because this one proved to be true. If this one was false, you go to the next if statement, which is basically saying else if this condition rather is true, do it. Else like that. Until finally you see that you cannot fit all the conditions and hence you are going to do the last one that does not have a condition. So that's basically the default. All right, so I'm going to go through this with you. If we have a normal condition which says if it rains today, I'll buy a car. Now, if it rains, you will actually buy the car because this is the condition. It rains today. Is it true that it rains today? If it rains today, then do buy your car. So that's a simple if. One if statement with a condition and then the action to be taken. Now, we have if and else. This one is a simple statement, but it's saying that if you don't meet the condition of that conditional statement, then do what is inside the else block. So the actions we perform are the ones labeled in green. So if student is male, then give him a pair of trousers. Else means nobody should tell you the student is not a male. Else means do anything apart from what matches the condition. Now, because of how the structure of if statements are, the moment we have a long if, the moment you enter the box for student is male, you are not going to come back into the else to also give the person a skirt. So if we have a block of if statements which are stacked plenty like that, we'll execute one of them in line and leave the next one. Go to the next one which says if. This time around you see if baby is a girl, we'll call her Linda. Okay. Else if. You can see this one is else. Else means go there. This one is saying else if. So the else if is now telling you, oh, I'm adding another condition to the first condition, making them look like they are a group of conditions that when you enter one, you cannot enter the other. All right. Or we have the next one which says if age is between 0 and 9, group under kid. So let's say a person comes to the post office or something of that sort. We check the person's age. If the age is between 0 and 9, we would say the person is a kid. Else if the age is between 10 and 17, we will say this is an adolescent. If the age is between 18 and 59, we will say this is an adult. Else we are going to say the person is aged. I'm not sure we'll get a person who will fit this condition and this condition based on the program that I've written. But if the person happens to fit the first condition, the second condition, I will not continue to check whether the person fits the next one because I've already done the action. That is basically the dynamism behind writing code, following conditions, and some not following conditions. That's why I'm going to break. I want you to go through. I'm going to do one last illustration, and the illustration will be more or less a question. So make sure you are ready. This one I asked the children and they were able to do it. So try and get it. Alright, so I'm going to have this. If you think like how we were doing mathematics in SHS, you'll get it wrong. We talked about the assignment operator. We've spoken about the fact that programs execute line-wise. So if I have A, wow. If I have A equals 3 or something like this, and I say B is equal to 4, and I come back to say C is equal to A star 3 minus 5 times B. I go down and I say print C, and I tell you print I'm going to say B is equal to A star C. And I come down, I say print B. And I say something like A is supposed to be given the value of B minus C. Print A, print B, print C. This one, the last statement is saying print A when you are done, print B when you are done, print C. That's basically what I want to see. So you have this assignment. I don't know whether I should do this for you or not, but according to mathematics, anytime we say B is equal to A times C, they are going to assume that is an expression. In programming, we don't have such equations, such that even if I go deep down the well, deep, you are still going to say A is equal to B is equal to A times C. In a program sense, we have a container, we put something inside. You come, if the thing is there, you pick it. If it's not there, you just say it's not there, and we continue. So over here, A is 3 on the first line, B is 4. On line 2, A is still 3 because we are in the next step, and that container called A has not been destroyed because the program is still running. We go to line 3. As of line 3, A is still 3 and B is still 4. That's why we'll be able to now use the values of A and B in our expression. So we are going to have something like the value of A, which is 3, times the value of 3, which is 3. So 3 times 3 is 9. Because there is a subtraction, if you remember what we did, 5 times B is 4, 5, 4, 20. So now we are going to have 3 times 3 minus, and now we have 5 times 4. This gets us 9 minus 20. So 9 minus 20 is equivalent to minus 11. Now we say print C. So C is now what? Minus 11. As of this line, A is still 3, B is 4, C is minus 11. Now we come here. Assign the value. So this is saying that replace whatever is inside B that you know with the value of A times C. The value of A is what? 3 times C is minus 11. So we have minus 11 times 3 means minus 33. That's one. Then we have print B. Print B is saying show us the value inside B now. You know from the top that B was 4. Now B has been replaced. So A times C is the one that's being put in the container. So we are going to have B being minus 33. So minus 33 is what is going to be printed now. Then we go on to the next one, which says A should be assigned the value of B, which is minus 33, minus C. C is minus 11. So minus 33 minus into brackets minus 11 gives us what? Minus 22. And now when you print the value of A, B, and C, you are not going to be looking at the container from the top. You look at the container from where it was replaced, anywhere we see an assignment. This side, we see the last value of A is what we are supposed to print here. So the last value of A is now what? Minus 22. All right. The next one is B. B had a value of minus 33. And C is minus 11. That's basically it. I'm going to be giving you examples of such nature. Make sure you rewatch the video if you don't get it. Prompt me anything you don't get.